changing climates, changing fisheries. Next, please. The scope is broad, but we're going to keep most of our focus on Florida. But it's very important to remember, of course, that Florida is downstream from a tremendous array of Caribbean sources of the things we love in the lagoon and in our coastal waters. When I notified of extremely knowledgeable fishermen in the southern lagoon about this talk, he sent me unsolicited a 2-page response full of ideas, and the first sentence in the response was, "An hour isn't enough." This wasn't a scientist. Okay, so you can expect that I'm not going to cover probably everything you want me to touch on. Many things I won't be able to go deep enough on. My goal right now is to do the big picture macro introduction to an extraordinary array of issues. It's funny, people talk about climate change. It should be plural. We have dozens times dozens of cascades. But don't worry. We can understand it, and we can do things about it. But we've got to know about it. So I'm going to give that a try. Can you all hear me in back? Okay, great. Real quick, come back. Sorry. There are over 35 countries in the Greater Caribbean, over 35 countries, 6 or 7 languages if you get down to some of the patois. Most of these countries have major fishery economies. That means they have major ocean and coastal and estuarine economies. You get out of the US, and it's not just for recreational and fishing and big-time commercial fishing, it's for survival. You hear about artisanal fisheries. Okay, so this is high-value conversation. Next, please. So the outline that I'm going to follows basically what I put out earlier. We're going to talk about climate change in the oceans. We're going to talk about impacts of climate change on Florida and Caribbean oceans and fisheries now and the future. And we're going to talk about what we can do. And you'll see there at the bottom there's 2 glasses. One is what? Yeah, and the other is half empty. Okay? I'm an optimist. I'm scary looking. I sometimes am saying things that are maybe some people might think of concern. We fix things. We fix things. But we have to move in time. So we can fix things. Next. So core attributes of climate change. This is technically challenging stuff. If your head starts to spin, that means you're smart. Okay? Climate change involves the geophysical sciences. This is meteorology and atmospheric chemistry, geology, oceanography. All these new ice sciences, new sciences are being, with new journals, are evolving almost on a monthly scale. We're learning so much. Many of the effects that we're talking about are nonlinear. That means they don't go like this. They jump around. That means they're hard to predict. And they co-vary. Think of the word co-vary, very important with any environmental issue. When people want the answer to some big thing at the scale of a watershed, there's lots of things bouncing off of each other. They co-vary, they influence each other. A change in A can change B and maybe Z in ways that we didn't know about. Okay? But again, we got it. We just have to understand the larger system landscape here. Next. As an example of this, a lot of folks don't know. I didn't relearn this until relatively recently, but liquids and air behave physically as fluids. Air is a fluid. Air is a low-density fluid. The atmosphere is a fluid, like the ocean. Okay? So there's a lot of fascinating science underneath this, and it's a fertile territory for science geeks, but a lot of people aren't cursed or blessed with that job. Most aren't. So we're going to try to go through at a macro high level here and telescope down into micro examples. And then I'm going to try to get through this in 30-ish minutes. And then we're going to have a lot of time for Q&A. And I'm going to stick around after. I'll stay here and sit around and talk till 2 or 3 for whoever wants to do that. Next. An extremely good resource is the NASA climate website. If you have an interest in this issue and you haven't been to this website, you should please go to this website. It has real-time data, real-time numbers from the most high-end university and government nonprofit sources for all kinds of major scientific metrics for climate change. And it has great drop-down resources if you're a teacher, if you're a citizen, if you're a decision maker. Next. As you can see, there's all of these real-time metrics with the databases and the metadata behind the databases. Next. Important, briefly, every major scientific organization, I'm not talking about something created 10 years ago by a corporation. I'm talking about the 200-year-old 100-year-old American Geophysical Union, the American Meteorological Society, the American Chemical Society. These are not radicals. These are very conservative, careful scientists. All of these organizations in the last 20 years have put out relatively profound position statements on 3 things. 1, the world is getting warmer. 2, a lot of it is created by human activity. 3, we need to redirect the trends or there will be big problems. This is not debated in the scientific community. I have a variety of flyers on this that I often would hand out right now in the talk. I have a 1-pager that's got this information on both sides. Please see me after, and maybe during Q&A I'll hand it out. Next. So the burning of fossil fuels produces inflows into the atmosphere of unprecedented megatons of carbon. Most people know a lot more about megatrons than megatons. What's a megaton? 1 million tons. It's how you measure atomic bomb blasts. We're putting in extraordinary amounts of megatons of carbon via simply the burning of fossil fuels annually, and the numbers are going up. We're talking about huge additions annually despite all of the people wanting to do something about it. Next. It's often been said that if you could see carbon dioxide when it's coming out of your tailpipe or whatever, you might be a little more moved. That's understanding. A lot of the political decision making about this is psychologically and socioculturally driven. There are hundreds of journal articles in behavior journals, science journals, about how decision-making about climate has become so ideologically polarized that people aren't looking at data often, fully, because you already have a decision that's been put upon you by your sociocultural landscape. So let's talk about it, however, next. The burning of fossil fuels releases what are called greenhouse gases. The primary ones that we're concerned about are carbon dioxide and methane. Yes, there are others. They trap extra heat while in the atmosphere. That's the greenhouse effect. What does a greenhouse do? It traps heat. That's why you have a greenhouse. I was in England recently. They had greenhouses so they could have tropical plants. It's a structure that traps heat. Okay, lots of ways to do that. Our cars would really be trapping heat right now, undergoing little greenhouse events if there was a fully sunny day, right? It's everywhere. The thing is that carbon dioxide has a residence time of 110 years, methane less, but methane traps even more heat. We're going to look at some numbers. The result is a rapidly warming Earth. Next. Okay. These are very resolved data from a government academic institution, the Carbon Dioxide Information Analysis Center. Look at this axis. These are millions of metric tons of carbon emitted per year. Early industrial revolution. President Carter made a speech, a clean energy speech from the White House in 1977, forgotten. That occurred about here. Since that speech, we've I believe, more than doubled the amount of CO2 that has gone into the atmosphere. It was a whole initiative that didn't get traction in 77. This is 10,000 million metric tons annual, and it's going up pretty much each year. Ironically, during the Great Recession, it leveled off. But it's back where it used to be. Next. So here's why this matters. There's no one killer slide that shows everything, but this one's pretty close. A 400,000 year timeline, which geologically is not a long time. The global atmospheric concentration of CO2 has never, actually, if you were to bring this out, it goes out now to about 800,000 years. The global CO2 concentration has never been above 300. Next. In 1950, it cracked 300 ppm for the first time in 800,000 years. The only explanation for that is what I showed you in the prior slide. And that's what all of these scientific societies are saying. It's remarkable how this is bouncing off of politicians. And look what has happened in basically the last 50 years, which is a heartbeat in geological time. Next. We're over 400 parts per million, right? Some of you, the climate geeks, know that. We're going up a couple more parts per million every year. Okay. So in 70 years, we've gone 100 parts per million beyond what we had done for 800,000 years. There's no doubt about these data, by the way. This is NASA, this is NOAA, this is every reputable university. You can argue about minutiae, but not the core meaning. Next. So here's what it means, and we're about to stop the super geek slides, pardon me. What that means is that the temperature of the Earth on a planetary scale, there is spatial variability if you go around the Earth. Everything isn't the same. Things are a little different in Alaska than here, than in Guyana. But at the global scale, we have seen with this rise above 400 parts per million in the last 130 years, post-industrial revolution, a rise of global air temperatures of almost 3 degrees Fahrenheit, which is this 1.5 degree centigrade number you might have seen that people are getting worried about. More carbon in the atmosphere when the levels are unprecedented. Those were thousands of megatons on that earlier slide, is increasing the temperature really quite rapidly. And guess what? The inflows of GHGs are increasing annually, despite all of the alarmist greenies waving their arms. Okay? Next. The last 5 years were the hottest recorded in the entire global temperature database combined globally. The last 5 years. They just came out with that in March. 17 of the last 18 years were the hottest ever. This is NOAA and NASA data and university data. The people doing this aren't, sorry, they're not paid by the fossil fuel companies. Isn't it ironic that one of the arguments against climate scientists is that the climate scientists are getting rich off of this? Our lives are there's all kinds of people doing climate science now who don't want to worry about this. I got into it almost 40 years ago for other things, marine sciences. And by the way, 2015 was the hottest year ever recorded, not only for Melbourne, but for Daytona Beach and New Smyrna. And 2015, 2016 weren't real good years for HABs, you might remember. We're going to talk more about that, harmful algal blooms, next. Okay, so this is what we're dealing with. You got to unpack this set of boxes, and every big box you unpack, there's 5 more things you got to unpack in that to explain like one stressor. We can do it. We can operate at the proper scales here. Next. So one of the mistakes that scientists make is that we're trained to use lots of charts and graphs and show how complex and smart we supposedly are. So we use lots of data like this. Snow cover goes down in a warming world. It sure is. We could talk for 30 minutes easy about what's happening to the world's glaciers. Oh, well, people can't ski anymore. The loss of these glaciers is affecting agriculture. The Pentagon and the Department of Defense are looking at that in big detail. So certain things, the measurements go down with a warming world. Next. Certain things, the measurements go up with the warming world. But is this going to work on the average, busy mayor who isn't trained in science or state representative? Does this work? No. I can tell you it hasn't worked. So one of the things that climate scientists are doing now is they're looking at the kinds of things that other people use to measure effectively, whether they're right or wrong. We are basically committed to accuracy, one of our failings in terms of political maneuvering. Next. So one of the things happening now is that I encourage folks, if you're going to talk about this stuff, try to make it graphical. Try to get away from complex charts. It's hard for scientists. It's really hard for people who don't look at these things all the time. And so here is an integration of the prior data-centric messaging tools with the more visual-centric messaging tool. Again, these are NOAA resources. Next. Okay, now let's talk a little bit more about climate change effects on the oceans and fisheries. I tried to get through that introduction rapidly and as thoroughly as time allows. We can talk more later, but I think a lot of people are really here to go deeper on that. I can tell you that in doing this, I was surprised at how much deeper this was than I thought. And I've tried to unpack a lot of it. Next. I've used a lot of resources. I was tempted to make a montage, 2 or 3 slides of 50 or 60 scientific journal articles on climate change that have come out in like the last 9 months. You cannot understand the tsunami and tidal wave of hard science, peer-reviewed journal science coming out on these issues. New journals are being created. So it's like trying to drink from a fire hose when you go into this literature. These are some of the things on different spatial scales that are of significant value. And the good news is we have some good things for the Space Coast and the IRL available to us, and we'll get to them next. This is an example from a 2017 review of drivers of climate change impacts in Florida. This isn't even the confounding factors. I left those off. So this one paper has a list of over at least 15 key drivers of climate change impacts for Florida fisheries. This isn't for Florida everything. This is for Florida fisheries and aquaculture. Okay, don't worry, we're not going to go through this. It's an example of the magnitude. Next. So with a lot of thought, looking at the literature, I'm putting this into 5 categories right here. Here they are. Can you guys in back read these? Great. Ocean and estuary heating, extreme weather, sea level, ocean acidification, and surprises. Okay. This is very similar to other categorizations of all of these things, but there's a few differences. And every one of these categories has multiple stressors inside that we could talk about for 10 or 15 minutes per stressor. If we had the stressors up, there's like about 30. So I'm not going to be able to tease out every one here. I'm going to hit upon the ones that seem to me, with not enough time to evaluate it, are the things most important for fisheries and ocean issues in this region and the Caribbean areas that I work in. So let's go through this. We're going to spend most of our time here. Ocean and estuary heating. Next. Okay, we often focus more on increases in air temperature. That's understandable. That's what you hear about. We can relate more to air temperature. We feel it as soon as we walk out the door. But in reality, 90% of the heat trapped by greenhouse gases since the 1950s is stored in the oceans, not in the atmosphere. This has only recently began to go out into the public consciousness, and it's because scientists are getting a little better at messaging. What did you learn in chemistry class? I know a lot of you didn't like maybe chemistry class in high school if you had to take it. What do you remember about water from chemistry class in high school? 2 words. Heat sink. Remember that? Well, it's a heat sink. Heat likes water. Water likes heat. It can suck it in and keep sucking it in. Next. Over 90% of the heat trapped by GHGs in the last 60, 70 years is in the ocean. There's no debate about this. Next. There's dozens and dozens of research articles. There's no debate. They're not debating about it. Maybe minutiae, but not the big picture. So what are the impacts of these higher temperatures? There's a lot. We'll start with algal blooms and fish kills. We're also going to talk about impacts to different habitats. I'm going to go through this quickly. This is an example of where I was saying earlier that thank you. I'm going to find some way to damage something by the end of the afternoon, I promise you, if you know me from my classes. This is an example of how I'm not going to be able to unpack everything to the entire detail you might wish, but we'll go through it and we'll have Q&A. So let's start with algal blooms and fish kills. Go ahead. Thank you. Put it like this. Warmer water means less oxygen in the water. That's another thing about water chemistry. You heat water, there's less oxygen available for animals. Warmer water means faster algal growth, right? Let's call the first thing A and the second thing B. When you have A times B, okay, and you have too many nutrients on top of it, you get algal blooms and fish kills next. If it doesn't matter to you, the A and the B part, maybe the dead fish all over your canal matters. I know it does. I know it does. Many, many global reviews and regional reviews are saying, well, we don't have all of the exact dots to connect a lot of times, but undoubtedly the heating of the oceans is a cofactor that can help stimulate and prolong algal blooms and fish kills. Okay, there's a large literature on this. So if you're thinking about ocean heating, think about the poor fish. Less oxygen is available to them to begin with, but then on top of it, with algal blooms, it's gone. So the heat is part of the problem, as well as the algae, as well as the nutrients. Nutrients, 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 yes, but also heat. Not good for estuarine waters in this century. Next. Seagrasses. A major review by Short et al. Summarized in several bullets. Hotter waters will be important stressors affecting plant physiological processes, growth, reproduction, distributions. Guys, just for one, or if you wanted to compare 3 species of grasses for each one of these factors, that's a 3x5 matrix. That's 15 variables you got to measure. And they're going to vary every week or month. We do know that there are all of these physiological stressor effects in every species of grass. Okay, we don't know the details yet. For those of you who are students, there's a tremendous amount of research projects being done in universities around the world right now looking at these kinds of things. Interestingly, and not surprisingly, the stresses from these temperature changes are most pronounced near the edges of the ranges of species. Okay, we can talk a little bit more about that later, but you guys know that the Indian River Lagoon is a transitional zoogeographic zone between warm temperate climate organisms in the Atlantic seaboard and subtropical organisms. So a lot of the animals in the IRL, they're at their thermal maxima. Okay, so what does it mean if things get warmer? They can move, they can die, they can all, for different reasons, that's correct. They can also expand their ranges or contract their ranges, right? So there's lots of 20-dimensional things changing here. Higher temperatures also increase extreme weather events. We'll talk about that quickly in a minute, which can include more rain, more runoff and turbidity, and reduced salinity, as well as direct physical damage. So, okay, we have more of this covariance, or one stressor, ocean heat, is producing effects on multiple scales. Next, mangroves. There's evidence that mangroves are already showing northward shifts in distribution, going further north. We also know that they're going deeper into the Everglades with saltwater intrusion and sea level rise, threatening freshwater vegetation in the Everglades. There's many covariables among sea level status and rain and wind events. You know, hurricanes can take out mangrove forests like they take out housing developments. Not always. So there's a lot of issues there. For seagrasses and mangroves, both losses and gains to marine plants can result from ocean heating. There can be increases in productivity rate with limited ocean heating, higher CO2 levels, yet there are a variety of negative consequences in the literature from other physiological and hydrological stressors. There's going to be some winners as well as losers. How long the winners will stay winners is questionable. With more and more losers, you're going to lose more and more biodiversity functionally, which typically isn't good for a system. Very, very exciting areas of research in the future with the effects of ocean heating and sea level rise, which co-vary on marine vegetation. Next. How about corals? Corals are animals that build calcium carbonate skeletons. They are animals. The resulting reefs have extremely high ecological and economic value. Importantly, corals coexist with photosynthetic algae. I think a lot of you know that. They are codependent. The coral needs the algae that lives in the coral to do its magic, to build the limestone skeleton. Got to have the algae. You might have heard of coral bleaching. Coral bleaching occurs when warmer water causes the coral to release the algal partners. Now, does coral bleaching guarantee that that piece of coral is going to die? Good answer. It often doesn't kill the coral in the first bleaching event. What if you have 2 or 3 more over the next 10 years? Yeah. The chances of mortality go up substantially, and the problem is we're having more bleaching events. They're becoming more frequent. The Indo-Pacific, the Great Barrier Reef has some real issues that no one saw coming. 20 years ago, they thought we were going to have impacts, but not this soon. The Caribbean. Next. So healthy coral, it's got these algae called zooxanthellae. When the coral heats up, and remember corals are often in the shallower coastal waters, they release the algae and it goes white, it becomes bleached. And sometimes it dies, sometimes it doesn't. Over time, with those events continuing and things like diseases, which they become more susceptible to, you can have dead coral covered in turf algae pretty fast. And once the algae is on it, then that coral typically isn't going to be able to come back easily, especially since we're removing all the upper level fishes, including herbivores. So we're removing algae off the reef less frequently because we're overfishing. Another cofactor. So, next. Diseases are amplified by climate change, not only in corals, but in other things. If you cut your skin open and you get like a typical kind of infection going, it's probably going to be better if you live in Finland than if you live in the middle of the Amazon. Heat can redirect infection trajectories in the wrong direction in many, many organisms. Okay. Next. Another big thing is changes in habitat and species distributions, which we touched on. I just want to say, I put these up here, that there's so much literature coming out. It's very difficult to keep on top of it unless you're in one specific group of animals. Here's a very highly cited thing that's a very strong paper. It's largely modeling, but they have data they're using where they're projecting shifts in thermal habitat for over 600 species on US continental shelves. Morley et al. Here's a paper that's telescoping down on one species that some of us know and love. I used to fish this 100 years ago in the Chesapeake Bay when I was a kid. The black sea bass? Offshore, black sea bass? There's a lot of shifting distributions. There's a lot of potential for shifting distributions. There is empirical evidence in some instances of shifting distributions. This is something stay tuned for, and I'd be very interested in hearing what some of the, if we have any commercial fishers or guides or serious recreational fishers, I'm curious in what you may or may not be seeing in the Q&A. Next. Changes in the experiences of fishing. Okay, I had to put this in there. This isn't just about the fish, it's about the process of fishing. It's a cultural phenomenon, it's what we do. You know what I'm hearing from a lot of fishermen right now? Fouled hooks. You put a line in, shallow, people like to fish the nearshore rock and nearshore reef in Melbourne when it's available, and you put a line in that water lately and you pull that, as soon as you hit that water, there's this green soup, round soup often inshore, fowls hooks. Captain Rodney Smith was telling me about how it's been very frustrating for those folks out there lately. Then I talked to people like Captain Ben Hardig down in Jupiter, who's fished commercially for 40 years, and he's really concerned about all the sargassum. They can't get their hooks either through the sargassum that's so dense and widespread, or they get this green filamentous algae. We don't have a genus name for this right now. Fishing offshore. We're seeing fouled hooks, and if you fish, you know that once your hook is fouled with algae, the fish are smart. They're probably not going to take that hook. Of course, fish kills can change the experience of fishing. Some species distributions are beginning to change. There's a lot of interesting things that are happening possibly with spawning seasons in fishes. We don't think about fish spawning maybe a lot. I know that if you're under the age of like 50, you're probably thinking about spawning a lot. If you're a human, it's what we do. Okay, but guess what? Fishes do it all the way through the equivalent of their age 80. Okay, and a lot of these fishes can grow, they live longer than we think. Spawning in fishes is, guess what it's closely tied to? Water temperature. So there's a lot of very interesting research on this right now. How is this going to affect this? It's not just when they go to spawn. There's months and months of lipid buildup, fatty buildup in the animals that are based on seasonal trends in heat and phytoplankton availability. So a lot of really interesting things here. Next. Extreme weather events. Okay, categories of climate change issues. I'm going to speed it up. The bottom line is that we've got dozens of these systems. Our droughts are going to become potentially more prominent, and our flooding events are going to become potentially more prominent without even getting into hurricanes. Sea surface temperatures are higher than they've ever been in the Gulf. You saw that thing turn into a Category 5 last year very quickly. Is that caused by climate change? Well, you have to be careful, but it turning into a Category 5 was caused by the highest sea surface temperatures in the Gulf of Mexico that we've been seeing, okay, in part, okay? The outer boundaries of the trends are getting more extreme. There's more runoff, there's more hydrological changes, there's more erosion, there's going to be more runoff. Next, sea level rise. Okay, we could do 6 hours on this. In short, I'm going to make it easy for you. If you really want to go into what the latest predictions are for this part of the state, please go ahead to the East Central Florida Regional Resiliency Action Plan. If you search that, it'll come up on the web. They had a sea level rise subcommittee. I and a variety of other people were on that committee. After a lot of work, the lower range that was chosen and the upper range that were chosen are represented on these plots based on a review of a tremendous amount of sea level rise research. Currently, the lower range planning projection that by the way, almost every city and all of the counties in the East Central Florida Regional Planning Council region worked on this for over a year and a half, I believe, or at least over a year, and signed off on this. Our planning guidelines now at the low end are 5.15 feet by the end of the century and 8.48 feet by 2100 by the end of the century. So yes, that's 5 to 8 feet by the end of the century. First learned about this in the 1970s, started working on this a little bit in the 80s, more from a management angle. From the 1970s to about 5 years ago, when we talked about sea level rise, what were we always saying it would be by the end of the century? 1 to 3 feet. Some of you might remember that. Yep. 1 to 3 feet. That's what we've said for like 30 years. Well, very quietly in the last decade, it's become 5 to 8 feet. Just FYI. Next. Well, we could talk about it here. We can in the Q&A. I wanted to show the Florida Keys. I used to spend some time down there. This is Plantation Key. That's Tavernier Creek on the right. Okay, you don't think of it like that. But guys, the Florida Keys, like a lot of places, is really overpopulated at low elevations. There's very heavy development at low elevations, very vulnerable to SLR. You can think of the runoff issues there. And by the way, the reefs and the Keys, for a variety of reasons, are increasingly being replaced by algae. Algae isn't only an IRL issue now. Everything's hotter. Everything's more nutrient laden. Next. Maybe this is where we're going to go. This is not as far out as it seems. A lot of people are starting to make a lot of money building designs of floating coastal communities. The Florida Keys, Monroe County folks, City of Key West folks, they're certainly willing to talk to people about this. Problem with these things is that they're too expensive right now. But it's a great idea. Solar panels, okay. This is a conversation that's beginning around the world, everywhere from the Maldives to London. The Thames is connected to the ocean. All over the world right now. It's going to be a fascinating century. There's a lot of opportunity to do the right thing and make money doing the right thing. Next. Caribbean islands, Pacific islands, the low islands. You know, there's the low islands, the Bahamas, the Caymans, Turks and Caicos. There's the high islands, Cuba, Hispaniola. Low islands have a variety of real important issues from sea level rise that are going to affect fishing and the availability of people to harvest fish. There's going to be substantial sea level rise. The water down there is even hotter. But in addition, you have saltwater intrusion that not only occurs in places in Florida, but occurs in islands. And it's even more impactful on islands because you have a smaller reservoir to dilute with saltwater. Right? Next. Then in the Caribbean, you have the high islands. This is a nice slide that shows, it's from Hawaii, but it's an excellent slide that applies directly to the Caribbean that shows a variety of issues that can be associated with having high elevation structures near the shoreline. This slideshow will be made available on the FIT sustainability website, so you can go look at these slides within a few days, okay, to get sources and information, okay? Next. The Caribbean. I worked in the Caribbean for a long time in Spanish. There are so many management agencies down there, and my main point here is that, okay, these are all different management agencies with the countries they're responsible for, and every single one of this set of alphabet soup fishery management organizations has documents that are coming out on how to prepare for climate change. Okay. Next. Ocean acidification. More CO2 in the ocean creates chemical changes in the calcium carbonate cycles that ultimately make the ocean water more acidic. For the sake of time and your sanity, I'm not going to go through this, but I will summarize it verbally. And you can go look at the slides. As I said, they'll be posted on the website I'm going to give you at the end in a couple of days. All right? Sound fair? Or you can look up ocean acidification. The main thing is what it says up top. Well, why does it matter if the oceans become more acidic? Well, what happens is it changes the ability of animals to make calcium carbonate. Well, what animals need to? Corals, mollusks, all the seashells. Guess what? All the bony fishes. And so there's a large literature of how fishes aren't developing their bones properly, et cetera, as the water goes more acidic and the calcium carbonate and marine calcium carbonate cycle goes out of balance a little bit. Just FYI. A lot of research happening here. Next. Finally, surprises are guaranteed. You know, we always look at, 20 years ago, people weren't talking about ocean acidification. They really weren't even trying to talk about sea level rise. So one thing that we have to stop ignoring is that we're going to be surprised. We should expect surprises. These are complex systems that are going to spin out things we didn't see 30 years earlier. This is actually guaranteed in systems science. They're called emergent properties. Climate change is this giant furball of surprises that are going to spin out, especially if we keep putting all of these GHGs into the atmosphere and rolling the dice. Next. And no, I'm not making this up because I teach systems science and systems science says it. This is well known that we're going to be surprised. The National Research Council of the National Academy of Sciences has put out very large, heavily peer-reviewed documents on this. There's a tremendous number of journal articles that are predicting the surprises that are coming. We could make those surprises good. By the way, there's good tipping points as well as bad tipping points. Maybe one of the most important things I can say. But good tipping points, when you're this far behind, don't happen by accident. They require directed action. Next. So we just went through this. Thank you for bearing with me. I just wanted to pause. That's what we just went through. Now we're in the home stretch. We're going to end it. And we're going to have a Q&A, and I'll stay. Like I said, I'll stay till 2 or 3. Next. Here's where we're at, what we can do. Okay? No. Thank you. We got one more section. This will be shorter, but hopefully as deep. What can we do? Well, I guess the people up front can see this, but what this says is, this headline is compassion fatigue amongst physiotherapists and physical therapists around the world. The key phrase there is compassion fatigue. Anybody kind of feeling burned out for all the caring you're doing? You should. Don't ignore it. Manage it. Maybe you got to take a step back. Okay? My guess is that there are already probably journal articles on compassion fatigue among environmental activists, and perhaps even as specific as climate activists, because it grinds you down. When you lay out on it for decade after decade and you see people just mocking the science and thinking about your children and your grandchildren and your great-grandchildren, it can be very fatiguing. So I want to acknowledge that moving forward. I'm not asking anybody here to go fall on swords, but maybe we can process and rearrange the chessboards and find space, or maybe down the road. My glass is half full. We won the Cold War and we didn't even know it. It just happened. there are major positive tipping points. There's peace in Ireland, relatively. There's major positive tipping points. They can happen. Next. So, when I feel really burned out and alone on something, it's good sometimes to take a step back and recognize there are a lot of organizations that care about this issue in Brevard County and in the Space Coast. I'm not going to name them all, but it includes, there's some good stuff, as you'll see, from the IRL NEP and their consulting contracts. The Thursday night, the Space Coast Progressive Alliance is having an important presentation on sustainable energy. Unfortunately, I've got to be at a sustainability meeting in Cocoa, and we'll miss that. But I hope a lot of you guys can go to that. And Daisy Chain, what we're talking about. We have a tremendous number of resources in the county, nonprofits, et cetera. And we also have these new and pending city sustainability boards around the county. There's 6 cities now, maybe 7, that have sitting sustainability boards that are looking at green energy solutions a little bit or a lot. Next. An important resource was contracted by the IRL NEP through an EPA Climate Ready Estuary grant. You can get this off of the web, I believe. The IRL Climate Vulnerability Assessment put out by Parkinson and Seidel in 2018. They have categories of stressors. They have different management goals, and then they rank them for their different attributes according to management goals. They come out with 154 different possible alternatives in terms of management by stressor. As I interpret this, this is a large document that I haven't gone all the way through, but I encourage folks to look at it. My primary point here is that the IRL NEP is looking at this and has serious people beginning the first steps of climate vulnerability assessments and next steps for hopefully adaptation implementation moving forward. There are many resources. This will be on the slides that get posted. Next. There are many things that can be done in terms of planning at the city level. Again, this will be on the slides. You can also get to this at this web portal. Many tools are available to deal with sea level rise. None of them are magic bullets, but in combination, they can help. Next. Would definitely encourage cities in Florida to examine adaptation action areas in their land use boards or planning boards. We did this in Satellite Beach. It was a long haul, but we got the first adaptation action area language in a land use plan outside of, I think, one other city in the state several years back. And that triggered a discussion which has borne a lot of positive fruit in Satellite Beach. And that was in 2013, 2014. So the things you see happening now have roots. Next. Next. So that's the Melbourne Causeway, that's the O'Galley Causeway. Look at our land use. Not bad compared to some places, but still not great. A super important thing moving forward is we have to reduce the amount of growth that's happening. We can't certainly water down existing growth regulations. The growth regulations have been radically watered down for decades. Okay, so a very important initiative is happening in the MRC. An octogenarian superhero, Professor Dave Botto, has been, after leading us out of the wilderness on nutrients over the last 15 years, is now pushing a lot of MRC board members and members to get involved on fighting some of the requests to weaken. Can you imagine that cities around are being addressed around our county are being having proposals to increase the density of building on the lagoon? It's happening all over. Let's start naming the cities. You know, so a lot of interesting things happening in Titusville right now and elsewhere. So more development, more growth is going to mean more muck, more wastewater. Add hotter water. Okay? So if you're interested in getting involved in very effective, they've gotten wins in the last couple of months, efforts to stop these developer-driven efforts to reduce the minimal, thank God we've still got a few regulatory preventions on overdevelopment. If you'd like to work that issue, Dave Botto, could you just raise your hand so people can see you? It's important, right? Get your hand up, Professor. That's Dave Botto there. Please see him after if you want to get involved, because he needs help and he wins. When he has enough soldiers, he'll go win. And he's a soldier's leader. Okay, thank you, Dave, for what you're doing, and the people, Steve, Ted, that are helping. Next. Okay, let's scale up. 2 more slides, I think, 3 more slides. So we're just talking about local things we can do, right? Well, you know what, guys, we got to do that. But acting local and just thinking global, it didn't work. We have to act global and think regional, and act regional and act global. So meanwhile, look over here. These numbers are higher now. We have to reduce GHG emissions. It was very well enunciated by the science, certainly by the early 90s, if not sooner. If we're going to do anything about this. And the good thing is you can bring the slopes of these lines down and the impacts aren't going to be quite as bad. Next. We can't let this get to 450 or 500 ppm, and it's going to be in the lifetime, a lot of you. It's going up like 2 to 3 ppm annual, guys. It's going to break 40, 50 in 20 or 30 years. 450 ppm. That translates into we're going to be getting close to 2 degrees centigrade, 3.6 Fahrenheit. We have to do something to slow down this growth rate. Next. So I said I was scaling up. We're ending. One of many solutions that we need at the national level is for Republicans and Democrats to come together and focus on economically beneficial long-term climate solutions. There is a climate, a lot of people don't know, a climate solutions caucus in Washington in the House. Republicans and Democrats work together. In order to join that caucus, if you're a D, you have to bring an R with you. Or vice versa. Okay? Next. Here's a list of the Republican members and the Democratic members. There's about 20 more Democratic members, but what's important is there's a lot of Republican members, and the chairs for both parties, Rooney and Deutsch, are from Florida. And another really cool thing is that Representative Bill Posey has recently joined. Our representative has recently joined this caucus. Okay, the local chapter, I know that's very interesting and impressive. It's not easy to do that for him. Okay? So, how did that happen? That happened via local lobbying and other factors, but a tremendous amount of lobbying by his constituents, many of them organized by the Citizens Climate Lobby. Okay? Yes. So we can move the rock up the hill a little, and we can sometimes move the rock up the hill a lot. So in terms of what we can do, I gave you a variety of local scale options. I gave you some national scale options. Next. I'll post the slides on this website within a few days. You can reach me at this email. There's a lot of resources. There's over 2,500 PDFs that are a couple clicks away from your desktop at this URL right there. And I'd be happy to answer any questions. Yeah.